The car industry is working night and day to bring to market better batteries that are safer, cost less, and have a longer range. Companies are spending billions on building the holy grail battery, but NASA has blown them all away as they unveiled a solid-state battery breakthrough that could change the industry. They claim they can get a range of 700 miles, which can be fully charged in under 10 minutes. Join us as we take a look at NASA's new sulfur selenium solid-state battery and how it changes everything. Since the Apollo moon missions, NASA has been pretty busy with a lot of cutting-edge research, innovation, and exploration in the realm of space science and aeronautics. While many of us may be familiar with some of NASA's past achievements, such as creating Tang and space blankets, the agency has been continuously working on a lot of remarkable projects and missions that have a significant impact on our lives. One notable aspect of NASA's mission is aeronautics, which focuses on advancements in aviation technology and aircraft design. A major concern in this field is finding alternatives to conventional fuels that emit fewer harmful emissions during flight. Just as electric vehicles have revolutionized terrestrial transportation by being more efficient and eco-friendly compared to internal combustion engine cars, NASA aims to apply similar principles to the world of aviation. While batteries have proven to be highly effective in powering electric cars, they are not that efficient for aircraft. They are both heavy and bulky, two words that aeronautic engineers never want to hear. Batteries suitable for airplanes need to be lightweight yet capable of storing vast amounts of energy to ensure extended flight ranges and payload capacities. Balancing these requirements poses a significant engineering challenge. So, scientists started thinking, what if batteries could store 2 or 3 times more power than the best lithium-ion batteries we have today? And what if they were also much safer, with no risk of bursting into flames due to any liquid inside? That would be a game changer, especially when it comes to airplanes, where fire is the last thing you want. The good news is that solid-state batteries have the potential to meet these demands perfectly. They offer higher energy storage capacity and improved safety, making them an exciting prospect for the aviation industry. Today, the aviation industry, like many others, is under mounting pressure to slash emissions and adopt greener practices. As concerns about climate change grow, airlines face increasing scrutiny to find sustainable alternatives to traditional fossil fuels. Solid-state batteries present a unique opportunity for airlines to revolutionize their fleets and significantly reduce their carbon footprint. For years, NASA has been at the forefront of battery research through its solid-state architecture batteries for enhanced rechargeability and safety, SABRES program. The goal of this program is to explore the potential of solid-state batteries, which offer numerous advantages over conventional lithium-ion batteries, including increased energy density and improved safety. Rocco Vigiano, the principal investigator for SABRES at NASA's Glenn Research Center in Cleveland, expressed enthusiasm about the program's progress, stating that SABRES has consistently exceeded its goals. The implications of their research are astounding, as solid-state batteries could revolutionize the way we use and store energy in various industries, particularly aviation. To understand the significance of their work, Vigiano likens a battery to a bucket that stores energy. A larger bucket can store more energy, and this is precisely what they're aiming for with their solid-state battery technology. NASA's sulfur selenium prototype battery, developed under SABRES, has an energy density of 500 watt-hours per kilogram, effectively doubling the capacity of conventional lithium-ion batteries. One of the main challenges of battery-powered flight has been meeting the tremendous power demands of aircraft during takeoff. Historically, lithium-ion batteries had the advantage of discharging their stored energy quickly, making them suitable for such high-power applications. However, solid-state batteries initially struggled to match this discharge rate. Fortunately, the SABRES research team, in collaboration with experts from Georgia Tech, has made remarkable strides in addressing these limitations. They have achieved a 10-fold increase in the discharge rate for their solid-state batteries compared to when the research project began. But the innovation didn't stop there. Building upon their initial success, they went on to achieve an additional 5-fold increase in the discharge rate. This impressive feat means that solid-state batteries now have a sustainably larger bucket that can be rapidly emptied when the aircraft requires an immediate surge of power. The implications of this breakthrough are enormous, and the potential applications extend far beyond aviation. The transportation industry as a whole could benefit from these advancements, as electric vehicles and other modes of electric transportation could see significant improvements in range, charging speed, and overall performance. Another significant breakthrough is that they were able to reduce the weight of the bucket by eliminating the casings around individual battery cells and stacking them on top of each other. By doing so, the overall weight of the battery can be reduced by up to 40%. This makes it perfect for aviation applications. The weight reduction is of paramount importance for aircraft, where every gram counts. Airplanes are designed with strict weight limitations to ensure optimal performance, fuel efficiency, and safety. Like earlier stated, lithium-ion batteries, while efficient in some applications, tend to be relatively heavy due to the casing needed to protect individual cells. Solid-state sulfur selenium batteries, on the other hand, manage to provide the same or even greater energy capacity without the added weight of casings. The absence of individual casings not only reduces weight, but also allows for more energy storage within a given space. This enhanced energy density is crucial for electric flight, where maximizing the energy-to-weight ratio is essential to achieve longer flight times and higher performance. The reduction in weight and size also leads to a secondary advantage: smaller and lighter cooling systems. Batteries generate heat during operation, and effective cooling is necessary to prevent overheating and maintain optimal performance. In conventional battery designs, bulky cooling systems are often required to dissipate this heat adequately. However, with the casing-free stacked configuration of the sulfur-selenium cells, heat dissipation is more efficient, thereby reducing the need for larger cooling systems. The result is a more streamlined and efficient battery pack that is well suited for the space and weight constraints of aircraft. There are other advantages as well. During takeoff, aircraft requires enormous amounts of energy, which can cause temperatures inside a battery cell to spike. Conventional lithium-ion batteries are prone to thermal runaway, a dangerous condition in which excessive heat leads to a self-sustaining chemical reaction that can cause fires or explosions. However, the solid-state sulfur-selenium batteries developed by NASA demonstrate remarkable thermal stability. They can endure temperatures twice as hot as conventional lithium-ion batteries without the risk of thermal runaway. Furthermore, these solid-state batteries show resilience to rapid changes in pressure, which occur during takeoff and landing. The pressure variations that aircraft batteries experience can affect their performance and safety. The only major disadvantage to this technology is the cost. Cost is a big factor. The rigorous testing protocols for new components in commercial aircrafts also add to the expenses. While a sulfur-selenium battery might be too expensive for individual passenger vehicles, it could make more economic sense for airlines and air taxi companies if the cost can be spread out over thousands of flights. Speaking of air taxis, there are currently two designs being considered. United Airlines supports a winged aircraft design that requires less power to stay aloft once it reaches cruising altitude. On the other hand, Archer Aviation's design is more like enlarged drones, and their rotors need constant high power to stay in the air, which results in high power consumption and a shorter range. NASA is actively involved in exploring the concept of advanced air mobility. They are dedicated to understanding how air taxis, robotic package deliveries, and emergency medical services can be seamlessly integrated into existing flight corridors to ensure safe and efficient operations. Forward-thinking minds in the aviation industry are already envisioning ride-share air services connecting homes to airports, making air travel more accessible to the public than ever before. The use of remotely piloted and autonomous aircraft is expected to play a significant role in this transformation. NASA's research focuses on finding ways to safely integrate these innovative aircraft into the existing airspace, while also delving into the necessary technology for a highly digital future airspace. They are exploring various design and operational options for takeoff and landing scenarios, as well as examining how these aircraft will be constructed, powered, and maintained. Through these comprehensive studies and research, NASA aims to provide valuable insights that will assist the industry in creating an optimal and accessible airspace environment. By collaborating with various stakeholders, NASA is actively contributing to the realization of a more advanced and user-friendly air transportation system for the future. What do you think about this? Let us know down in the comments section.